In these modern days, finding car parking may be a big issue in congested cities. There are too many vehicles on the road but not enough parking spaces. One of the biggest problems is when we enter a parking area then we realize that there are no empty parking slots to park our cars. Another biggest problem is after entering in a big parking area, we're confused to find the empty parking slot to park our car. Sometimes maybe we all have been facing these two problems that wasted our important time. Hence, we need an efficient parking management system in all parking areas that will provide confusion-free and easy parking. In this project, we designed a smart parking system using Arduino called Automatic Car Parking System to overcome this problem. This project helps the car driver to park their car with minimum wastage of time with accurate information of the availability of the space to park. The hardware that was used in this project is the Arduino Uno, IR sensor, LDR sensor, LED, and servo motor. Arduino Uno will act as a microcontroller. We use two IR sensors and the LDR sensors as the inputs. Besides that, we use two servo motors, a white LED, a red LED, and also LCD as our outputs. For detecting the movement of vehicles, we are using the RR sensors, and to display the parking status, we are using a LCD. This system is capable of finding the empty slots that are available for parking automatically. If the slot is empty in the automated car parking, the new vehicles are allowed to enter the parking, else the entrance is blocked by using the servo barrier in case no empty slot is found by the system. The visitors can see the status for the availability of free space outside the parking on the LCD. We also used LDR sensor to turn on like at the car parking during night, so it helps visitors to see the empty slot parking clearly. This smart parking system project consists of Arduino Uno, two IR sensors, two servo motors, a LCD display, and LEDs, where the Arduino is the main controller that controls the whole system. Two IR sensors are used at the entry, IR sensor 1, and exit, IR sensor 2 gates to detect vehicle entry and exit in the parking area. There are 4 parking slots in this project, therefore these IR sensors are used to count and detect the parking slot availability, simply just allowing and releasing the car at the entry and exit by 4 times. In this way, this system automatically allows 4 cars only. The servo motor is placed at the entry and exit gate that is used to open and close the gates after the presence of a car. When a vehicle arrives at the gate of the parking area, then the IR sensor 1 detects the vehicle and the system allows to enter that vehicle by opening the servo barrier. Similarly, when a vehicle leaves a slot and arrives at the gate of the parking area, then the IR sensor 2 detects that vehicle and the system opens the servo barrier. Also, an LCD display is placed at the entrance, which is used to show the availability of parking slots in the parking area. When a vehicle arrives at the gate of the parking area, the display continuously shows the number of empty slots. In the beginning, when all parking slots are empty, the LCD display just shows slot only, and then if a car is entered, they will show slot 3, indicating the number of remaining slots. In case the parking is full, then the LCD display will show slot 0 and parking full. After that, when a car leaves a slot, then the LCD will show slot 1, indicating the number of remaining slots. Again, the system will allow entering a new vehicle. A red LED is placed at the entrance to indicate and lights up when the parking is full. Besides that, a white LED is placed at the parking area for lighting purpose during the night times. This LED is controlled by a LDR sensor. The LDR sensor is used to detect the intensity of light darkness so that the white LED can automatically light up during night times.
This is the flowchart that represents the overall concept of our automatic car parking system. At the start, the IR sensor at the entry gate is ready to detect the car and will allow the car to going in by opening the servo barrier. At the same time, the system will count the detected car value and then it will keep updating the display by showing the remaining parking slot number. This system will count until 4 entry only because our maximum slot is 4. Once it's reached the maximum value, the display will show parking is full. And then similarly, if a car is leaving the parking slot, at the exit gate, the IR sensor will detect the car leaving and allow the car to going out. At the same time, the system will count the detected leaving car and will update the display again by showing the remaining parking slot number.
Okay, Assalamualaikum. So my name is Muhammad Sufi Arif. Okay, I will present for the circuit diagram part. Okay, for the first one, we have a first IR sensor. For the VCC, we connected to the positive. So for the ground, we connected to the negative at the breadboard. Okay, so for the pin, we connected to the pin number 2. Okay, so for the second IR sensor, it's the same as the VCC. We connected to the positive, and the ground we connected to the negative at the breadboard. And for the pin, we connected to the pin number 4. Okay, so for the LDR sensor, at the bottom is VCC. Okay, VCC we connected to the positive breadboard, and the ground we connected to the negative. Okay, for the DO pin we connected to the resistor. Okay, so we connected to the resistor. Okay, for the positive white LED we'll connect it also to the resistor, and then the pin will go to pin number 10. Okay, so for the servo motor, the black wire go to the negative for ground. Okay, so the VCC will go to the positive, and the PWM go to the pin go to the pin number 3. Okay, so for the second servo motor, the black wire will go to the negative, the red wire will go to the positive, the brown wire PWM will go to pin number 6. Okay, for the LCD, the ground will connect it to the negative, the VCC will connect it to the positive, the SDA will connect it to the pin number pin F4, and the SCL will connect it to pin A5. Okay, so for the last one, the red LED, the positive one will go to the resistor, and the negative one will go to the negative, the ground one. And for the resistor, we connected to the pin number 9. Okay, so I think that's all. Thank you. Assalamualaikum. So my name is Muhammad Sufi Arif. I will represent from the group 9. Okay, today I will explain about our project car parking system. Okay, first of all, the car will enter at the front of the parking lot. The sensor will detect the presence of the car, and the motor will open the bar. Okay, so for the second car, the slot will become 2, and for the third car, the slot will become 1, and for the last car, the LCD will display the full parking, and the red LED will light up. Okay, for the exit, for the first car, when there is a slot, so the red LED will not light up, it will turn off. Okay, for the exit, the system is the same as the previous one. We're using IR sensor and servo for open the bar. Okay, after that, at night, the LDR sensor will turn on the white LED. Okay, the white LED is represent as the automatic light. So this is our car parking at night. Okay, I think that's all. Thank you.
In the conclusion, we learned how to simulate Arduino to control and measure the analog digital input and also output. We are able to simulate Arduino using ISYS Professional to control and display output at LCD. We also understand a debugging method for troubleshooting. From this assignment also, we were able to create a new project and understand how to use and connect all the components properly. Our smart parking system project is planned to be integrated with another software application to help drivers to find the empty spot in the parking lot more easily with less time. Also, our project implements most of the functionalities needed in a parking